also positive. So you can see that positive to positive, what will happen on that. So here for this circuit, we can write that R1, R1 as a load, okay? So they will lost energy here, and then they will lost energy for R2, and also here, because the polarity is the same, so it will be a loss for this circuit, because in previous times some students think that, oh, plus plus, plus terminal, it become they add the value. And then also, because the positive should be end to the negative terminal, okay. So another one is here, which is R2, okay, also minus, and also for R3 minus, and then come back to the original location or position of the source, then become add, and then you also will minus the another source, another load here, and then we can uh, combine all these into Ohm's law, and then you will get V1 minus V2 over the total resistance in this circuit, and then you can calculate the current. Okay, so that is what you understand before, and you familiar how to calculate R1 and R2 from the circuit. When you, the starting working step is correct once you collect all the negative parts and positive part, and then you can calculate, for example, in this work, let's say E1 and E2 is 10 and 5 volts, and then you just plug in the values, and then you will get the I value. Okay, so so from here we can have I, and then but you notice that the value is negative if I1 is 5 volt and E2 is 10 volt. Okay, so that's mean our assumed direction of current must be reverse. Okay, so you have to notice that you can simplify this, and then you can add all the resistance, and then get the total resistance, and then you can have the correct values for the second option here. So in summary, you can say that the battery one, the current flow from negative to positive in battery E1, and the current flow from positive to negative for battery E2. And then we can say that the electrical potential energy in battery one increases and decreases for the battery two. Okay, so let's say we have this example. Okay, so we have the value of resistance in ohms, uh, a single digit in ohms, and then what is the current in the circuit. So we want to calculate. So the current in the circuit. So you have to careful with the polarity of the battery here. Okay, so we assume that we take starting from this point, and then the current will flow in clockwise, and then you have a quick solution here, which is 12 volt will reduce the potential with 4 volt, and then because this one negative terminal, okay, then they will increase back the potential, and then the total potential for this whole circuit is 10 volt. And then we total up the resistance values in this circuit. So we have 1, 5, 5, 1, 1, and 3, and then will give us a total of 16 ohm, and then we can calculate I equals to 10 over 16 ampere. Okay, so in another approach, which is we will write the equation for the loops is you can separate parts of voltage like here. So the same thing. This is the working step for this one, and then the same thing you will get the values, and then okay, this one will be harder, which is we have multiple loops. Okay, so the same concept we apply here, which is we should carefully look on the voltage the terminal of the battery here. So we have 12 and also 3, and then this one is the current loop. Okay, that's mean for this loop is I1, and then for this loop is I2. So that's mean the current I1 will flow from 12 go to 6 kilo ohm, and then go down. Sorry, and turn go back. Return back to the 12. Okay, so you notice that this one 6 kilo ohm resistor here, because I1 go in, and at the same time I2 go out from this 6 kilo ohm resistor. So there is a you should have the total current that give impact to this resistor of 6 kilo ohm. So we will use that strategy when we apply mesh analysis method. But in previous time, maybe you already know how to calculate this equation using a loop analysis, in which you will label the first root as a loop I2, okay, and the second the first loop, which is here, and then the second loop you will across, starting from the same power source and then go back to the same power source. Okay, so I hope you can see the difference between these two technique, which is in this technique we consider the total current that across at the 6 kilo ohms resistor. But here actually for the loop analysis, it will exclude the total current flow, across across 6 kilo ohm resistor. Okay, so we can write a KVL around the closed loop in the circuit, and that's why I've been teaching this subject quite long time, and then student keep asking me uh, mesh analysis is the same with the loop analysis. So I said no, it looks like similar, but actually not the same. Okay, maybe some part is similar, which is how to write. In loops equation writing. Okay. Okay, don't forget to click your attendance in Spectrum. Okay, so next, we want to know how we can apply Kirchhoff rules for multi loops. And then you can have the total voltage. You will get the total voltage drop, which is equivalent to the total voltage rise. And then at any junction, you should apply that total in equals to total I in equals to total I out. And rule 1, for example, here we can write two loops here, which is 1 and 2 here. So we will have for loop A, okay, here loop A, we have 12 minus 4I1 minus 3I. Okay, this one is I. Okay, because this one is I this one is I2. Okay, so at any junction, total current in, masuk, in, out, I2 and I1. Okay, so that's why we get this one, which is I equals to I1 plus I2. Okay, then this one I, we can substitute into here, which is 3I. Okay, then what will happen? We will have three unknowns here. Nampak keluar. Okay, so you have insert the I2 plus I1, okay, for the I part, and then you will get 12 I1 minus I2 equals to 0. Okay, and then for the second loop, you have -5 plus 4I1 minus 2I2. And then we can have simultaneous equation. So you can multiply equation 1 by 2 and equation 2 by 3. So after this part, okay, you will have this one, okay, as the result. Then uh, we can subtract them, okay. Actually, this one only two unknowns, which is I1 and I2. Okay, and then you subtract them, then you will have this value, which is 39 minus 26 I1. And then from here, you can calculate I1 values here. And then you can also get I2 after you substitute the value of I1 in one of these equation. And then finally, you can calculate I because I equals to I1 plus I2. Okay, clear? Then another method to solve this problem is we call it Cramer's rules. Okay, so Cramer's rule, I think everyone knows because it's similar to the matrix solution. And then these Cramer's rules, if I'm not mistaken, already covered. This topic already covered in Maths 1. Okay, so you can use Cramer's rules. Okay, so this is example. This one is general equation for Cramer's rule. If you have three unknown parameters, and then you should recall back how to evaluate. Calculate the cross product of two vectors. Okay, and then for example, if we want to solve for I here, so we have to know the determinant characteristic, and then you plug in the values at its own position, and then finally you will get the value of I. Okay, so for two unknown parameters, whether if you are comfortable to use substitution equation also can, and some students they prefer to use Cramer's rules. But in exam, you should show this step. Okay, so many times every semester, student just write equation this one, okay, and then using Cramer's rule, we will get this one. So frankly speaking, you will not get full marks for that kind of solution. Okay, so we go to next example when we want to calculate all the currents and also determine the direction of current flow for each resistors. And then for here we have loop 1, and then we have a loop 2 here. Okay, so here we have I in, okay, here, and then go out as a I2 and also I1. Okay, so but you have to take note on the battery part here. Okay, and then for at the this junction, okay, we can have I1 equals to I2 minus I. Okay, sorry, I equals to I1 plus I2, or I1 equals to I minus I2. So then loop 1, we write the equation for loop 1, which is we start with power source here, which is battery, and then we start as positive, and then this one fall at the negative terminal, and then we add to the 8 volt, and then here it fall at the positive terminal, so we need to deduct it, and then another what we call load, which is 1 3 1 and 2 become 3 ohms, okay, for I1, for I current, but for 2 ohm it experience of current I1. Okay, so here again we look at this part, which is 3I1. So I1 equals to 3I, sorry, 3I here, and 3I, the I equals to I1 plus I2. So you substitute these values into here, okay, and then you will get this one, okay, which is 8 minus 5I1 minus 3I2 become equals to 0. And then for loop 2, okay, so loop 2 looks simple, which is we have 6 I2, because this one is load, and then you should minus it, and then plus with 4 volt, and then plus with 2 uh, I1. Okay, so here you can see because just now go down is minus, so when go up it become positive. Okay, then I will use equation, simultaneous equation, and then you can multiply the equation 1, which is for loop 1 here, okay, by 2, and then you can subtract from the equation of loop 2. Okay, so here this is the final product for the subtraction, and then you will have 12 I1 equals to 12. So definitely you will get I1 value. Okay, so I1 is equal to 1 ampere here. Okay, then you substitute this value into any equation that you comfortable with, and then you will get I2 as 1. So when you refer back to the current equation at the junction between at this point, okay, so you will have I. So I is 2 ampere because 1 plus 1 ampere. So there are few tips to solve multiple loops circuit, which is the first one. We choose direction of current in each loop, or in other words, we decide, okay, you want the current flow. So you have to label the current flow in each loops. Okay, then you start with write the junction rules equation for each junction. Okay, and also you can apply loop rules depends on how many loops, and also interior loops that exist or present in the question. And then number 4, you solve the equation for the unknown. Okay, so some, if you don't prefer a Cramer's rule, maybe a little bit long. If you use simultaneous equation, you decide whether you want to use Cramer's rules or any approach that suitable for you to get the final results of the current or voltage. As requested in the from the equation, from the question. And lastly, you have to check. Okay, but this one I think most of student will not do this part, because when we check from step 1 and step 2, okay, even though correct, but sometimes there are mistakes in the mathematical part. Okay, so I think number 5 is not preferable to be practiced by student. Okay, so we proceed with the third example. Okay, now we want to practice how to write a loop equation, and also for this question we want to calculate I1 and I2. Okay, so my advice, carefully look at the circuit, because some student, they confuse. They will think that I1 is for R1 and I2 is for R2. No, you have to check, because normally the question will label the current I1 or I2. Okay, and then the same concept we apply, which is total potential. Okay, first of all, how to check? So you have to check the polarity of battery, and then you check any junction. So now you already notice there is one junction here, and then another power source here, and in between of the loops there is a only resistance, because if there is a power here, power source here, that one is another technique. Okay, so now we have total potential. We want to know total potential, because we want to know how much the energy lose in this circuit after it across the resistor. Okay, so we have a total potential here, which is a minus with total load, and then it become 0, as I showed in slide 2 or 3 just now. And then we can rearrange this equation, so the total potential will be the same with total load. Okay, so for this circuit, we look at the first loop, which is loop 1 here. We identify the total potential, because in this loop only have one power source, which is 10 volt. Okay, settle. And then we go to the total load. Okay, here we have 1 and 2, but resistor 2 experience or influenced by I1 and I2. Okay, never mind. So now we want to calculate the total load. So 47 experience with I1, and then the same thing with R2, which is 22 I1, and then R2, which is 22, also experience I2 current flow through it, but in reverse direction. So this one should be minus. So indirectly, you have 47 I1 plus 22 I1 minus with 22 I2. Okay, and then you can write like this. Okay, because we try to accumulate at one parameter for of the values, and then you can write this equation as equation 1 because total potential here is 10, and then you have load as equation this. Okay, we proceed to the second loop, which is we have potential as a negative 5 volts. Why negative 5 volts? If you check from the diagram, it is in opposite direction. Okay, and then the next process, we want to calculate the total load for loop 2. So this one definitely I2, this one also I2, but R2 experience I1 in reverse direction. And the same thing we can put as a minus 22 I1. Just now, for loop 1, you see, we put as minus R, I2. And for loop 2, we put minus for I1. So I hope you understand here. Then you will have the equation for loop 2. The full equation is like this, which is we have negative 22 I1 plus 104 I2 equals to negative 5 volt. So this one is equation 2. So at this step, you already have equation 1 and equation 2. So it's up to us whether you want to use Cramer's rule or simultaneous equation, but I think I will choose a simultaneous equation would be easier because we can get calculate it straight directly calculate I1 and I2. So if you want to use Cramer's rule, so this is the example. Okay, how to put the um, values for at its position. So refer to the general um, formula for Cramer's rule with two unknown in the equation. Okay, so finally, you calculate from this Cramer's rule, and then you will get 139 milliampere for I1. Okay, and then the same thing you can do for I2, in which you will get negative 18.7 milliampere. So the negative sign I2, it shows that a sign direction is opposite to the actual current. Okay, next part, I add another loop, okay, in the equation, which is we have three loops. Okay, as what I told you just now, we check the diagram, the circuit diagram first. So you can see that we have source here, and then we have resistor. So there is no power supply in between of two loops. Okay, so the same thing here. Okay, and this one is polarity of the battery. I think you already know how to label it, and also determine the direction, the signal for this power source. So we have total potential minus total load. And then for loop 1, here we label loop 1. So the total potential here, because there is no power source attached in this loop, so the total potential would be 0. But we have load, okay? So the load, we can start from the upper one, which is upper resistor here, which is 47 ohm only experience with I1. Okay, and then we have R3, which is also experienced with I1, but at the same time it experienced with I3. Okay, and R2 experience, receive a current I1, but direction of I2, which is across uh, to this resistor in reverse direction. So end up you can calculate, or you can write the equation as 47 I1 plus 33 I1 plus 22I1. So you take the first I1, okay, the first current, and then you deduct with the current that flow into the elements, the second element in reverse direction, which is here we have 33 I3 and also 22 I2. Okay, and finally you will have this equation as your equation 1. Okay, so the next part we proceed with loop 2. Okay, the potential for loop 2 is 6 volts here, very clear here. And then the same procedure we will use to calculate the total load. So because this one is I2 loop 2, so we will take 22 I2 plus 10 I2, and then they also experience with current I3 and also I1 in reverse in opposite direction, which is minus with 22 I1 plus 10 I3. So indirectly you will have a negative 22 I1 plus 32 I2 minus 10 I3 equal to 6. Okay, so then you continue with the third loop, which is here is 8 volt. Okay, so then because it fall at a positive part, so it become positive of 8 volt, and then total load again we have 33 I3, 10 I3, and then minus with 10 I2, and then minus with 33 I1. Okay, and then finally you will have equation number 3. Okay, look simple, right? And then we have 3 unknowns here. Okay, whether you okay, you want to use a simultaneous equation, so that's mean you will have another um 9 step, which is 3 step for subtraction or addition equation 1 and 2, and then you get the value of 2 unknowns, one unknown, and then you substitute to another equation, and then you substitute another equation, and then you solve, yeah, I mean internally for each part. So here we use Cramer's rule, and then we can have a characteristic determinant here, and then you just put in the right column for each values, and then you will get a 59,927, and then I3 determinant as this one. So the same thing, you have to put in the right column. Mm, if not, you cannot get the value, and then finally you will get I3 as 0.55. So you substitute value of I3, which is equal to 0.55 in the equation 2, and then you will get equation 4 like this. Just substitute, and then from here you will get another one for from the equation 3. So you have 4 and 5 as new equation once you substitute the I3 values, and then you can use simultaneous equation, and then from the equation 4 you divide by 2, and then where is equation and then equation 5 supposed become 6 and 7, right? Okay, then you will get this one. Okay, just use the addition for the simultaneous equation, and then you will get I2 as a 0.57. Okay, so from equation 1, just now for loop 1, which is as here. Okay, so you just substitute I2 and I3 into the equation 1, and finally you will get equation 1. I1, mm, which is 0.30. Or can we check back here? Because this one I1, I2. Oh, if we have, okay, this one is I1, this one I1 go in. So more complicated if you want to use current junction equation here. Okay. Okay, so that is for two loops. I already show a single loop, how to solve it. And we have two loops, multiple loops. I show 2 and 3 loops. So if you have 4 or 5 and n numbers of loop, that is the procedure how to solve the equation. But I think up to now I have tasted student, I mean examined them for maybe I think 5 or 6 loops in the final, but the same procedure. Okay. But if 6 loop or 5, 4 or 5 loops, that means the working step is quite long. Okay. Plus with the math skill, finally quite difficult to get final answer. Okay, so that's why I advise all of you practice how to solve simultaneous equation, because that is depends on you which approach you want to use. For example, here, even though succeeds in Luke's equation writing here, okay, maybe you will take a longer time when you want to solve one by one. But I know you can calculate this one using calculator. Just and finally you get the answer, right? But if you stop here and then you just put the value I1, I2, and I3, you will not get 100, full marks, because the effort should be valued by examiner, right? Okay, so any question before I proceed to the next slide? Is it okay? You can follow? Okay, so next part, okay, this part is quite tricky. So if, okay, let's say, if you do not um, write, or if you do not polish your skill in loop equation writings, if you have dependent or independent source, especially dependent source, it will be more confusing, and also it become more difficult for you to understand. So we start with if we have independent voltage source. So you see the symbol is round shape, and then beside the symbol we will give the value of the source. So in this case is independent voltage source for 5 volt. The right side figure is independent current source, which is 3 ampere, and you also will see dependent voltage source where we have because dependent, so that's mean there is a parameter uh, at the source. Okay, so that's mean the polarity of the dependent source will control control the variable uh, and control the current flow through in the circuit. Okay, so this one, the diamond shape is for dependent current source. Okay, so current dependent on voltage, and for the left side is voltage dependent on current. Okay, so that is the, I mean, a simple definition dependent voltage source. Okay, this one just to show that dependent, which is referred to the control source, which is active element, which is controlled by the voltage or current another element. Okay, so this is the example of the circuit in which you have a dependent source here. This one voltage, right? And then if you see Ix, so it will voltage source will be controlled by the current. Okay, so this parameter should be the same. Okay, so the same thing from here. Okay, which is current, which is a Vx over 1000, and Vx is the voltage across to the resistor. Okay, so the same uh, type of circuit will be appeared in the Thevenin, nodal analysis, Norton, and superposition. So this one is independent, which is a round shape. Okay, which is it refer to the fixed values of the source in the branch. This one is common, I think. Okay, so here is independent voltage example. You want to calculate current I1, I2, and I3 as shown in this circuit. So you can use the same concept of double loop or two loops equation, which is total potential equals to the total load, and then finally you can, I mean, before you reach the final destination, you have to write the um, loop equation. So I show you different concept here because the just now the loop is positive, right? But if you want to change the direction, let's say you want to assume that this one is negative because you understand the voltage rise, something like that, or voltage drop. But the main thing is consistency. Okay, so if you consistently use the concept throughout the whole loop, you will get the answer. Don't do some part you follow this rule, some part you say add become positive, voltage rise become positive, some part you say voltage rise become negative. So your calculation will be not in order. Okay, so we use a simultaneous equation, and then you will get a value of IA equals to for the loop A and loop B as 4 and 1, and you just plug in into the any equation, then you will get the value of I1, I2, as well as I3. Okay, this one in ampere unit because this one is for ohm. Okay, and then loop this is I want to show what we have discussed before using the same circuit. Okay, here, so total potential equals to 32 here, and then the load, you go one by one of the circuit element resistor in this circuit, which is 2IA plus 8IA minus IB. Okay, you understand why minus IB, because the influence of the next loop current. And then you will get equation 1 as this one, which is 10IA minus 8IB equals to 32. So proceed to the next loop, which is a potential given as 20 volt. Okay, you understand, because current touch the positive part, so become negative here. And then we have a total load here for an 8, but 8 ohm experience two types of current, which is IA and IB, but IA in the reverse direction. And then finally, you will have 2IB minus 8IA minus equal to minus 20. So simultaneous equation, before you perform this equation, you have to multiply the first equation by 4 and the second equation by 5. Okay, I think this one is basic thing. And then finally, you solve for IB, which is IB equals to 1 ampere. So once you get a 1 ampere for IB, you can substitute into equation 1. And then from this equation 1, okay, you will get the value of IA equals to 4 ampere. Okay, so I hope you understand the step to solve the problem. Okay, but the main thing is to practice. Okay, and then next part is at the junction here. So we have I1 go in. So this one is the junction. So I1 is go in, and I2 is go in. So that's mean I1 plus I2. But I3 is go out. So you minus with I3 and then become 0. And then IA and IB you already know the values, and then you just use this junction rules, and then you will get I3 become 3 ampere. Okay, so this one is equation mesh analysis for the network, but you see the arrangement of voltage. I have to show, even though the concept is the same, but uh, at least we practice how to write the equation for loop 1 here, loop 1, and then this one is loop 2. Okay, so you can write equation 8 plus 6 plus 2 for I1, but for 2 ampere experience reverse direction of current I2, and then we have the total potential as 4 volt. For second loop, the same thing we do for second loop, which is 7 plus 2, but the uh, reverse direction of current I1. Okay, deduct, and then finally you get 9 volt. And then why negative 9 volt? Because it fall at the positive terminal here. And then you get the two equation here. And then finally you can calculate using simultaneous equation, or you can write or calculate using Cramer's rule, and finally you will get I2 equals to negative 0.97 ampere. Okay, so this one after you master to I mean in equation writing, in loop equation writing. So I show you in this slide how we manipulate the loop, the shape, the type of loops. Okay, in the equation. Okay, so this is one of it, because normally maybe you think that, oh, the question would be asked, what is I1, I2, I3? Okay, I1, I2, I3. We also can calculate the current that flow through one particular element. Okay, which is I'm not so sure whether it's simple or not to you, but to me it's simple. But the first step is loop equation. Okay, the same concept, total load. Okay, here total load, and then sorry, total potential, and then this one is total load. Okay, so this one you have to balance these two parts. Okay, so eh, okay. Okay, so next part is you have the three equation of simplified part for I1, I2, and I3, and then you can distribute all the values into a column I1, I2, and I3 if you want to use Cramer's rule, and then you will get values of I3. Okay. So if you want to use a simultaneous equation, you have to be careful because in each equation, okay, 1, 2, 3, they have I3. Okay, so you have to choose whether which approach that more easier for you, because we know that for 10 ohm resistor only I3 across it. Okay, if we ask I mean, let's say we change the resistor value, I mean in this equation, in this question. So for example, for 5 ohm, that's mean for 5 ohm resistor, 5 I3 in, I2 out. Okay, so you have to get the resultance value. So that is the basic concept for each that you can use or you can apply for each elements in the resistor. So you have to determine, you have to label which current go in and go out through the elements. Okay, then you proceed to create equation for the networks, I mean for the loops, for each loops, and then at least after you able to write this equation, at least 30% is in your head. Okay, because at here, for example, it takes a long, I mean a longer time compared to here, because you need to solve this part carefully. Okay, so to be safe, the first step that you need to do, redraw the circuit in your answer script and label it. So to be detailed, you can have I3, I2. You can show like this. So you yourself understand that in this part they have two. Okay, this part they have two current experience, and this part they have two current experience, but this one is only one. Okay. So the next part, we only talk about current and then resistor. So how about voltage? So voltage very simple actually, because we will apply Ohm's law, because once you already know I and R, current and resistor, you definitely can calculate voltage. So you can you can you able to calculate a voltage across each elements. Okay, so I give you example here for two loops circuit here, which is VA and VB. Okay, so we have A point here, point A is here, and point B at the junction. Okay, because at B junction you already know the flow of current here, because we have two current in, which is I1 and I2 into the node B, but I3 go out from the B. Okay, Okay, but the potential difference between point A and point B, so we can say that 32 is included at the point B, which is the difference of the potential, which is IA, which is I1, sorry, I loop I1, IA, and then flow through 2 ohms here. So just now we have IA equals to 4 ampere. So the voltage at B we can calculate using this equation here, and then we plug in the value of IA, and then you get the value of IB. So at B point, the voltage is 24 after they cross 2 ohm resistor. Okay, so another example, which is we have two loops. Okay, but we mix the source. Okay, this one voltage source, this one is current source. Okay, so in previous example, I only consider voltage source. Okay, if you check only the voltage source. Okay, now we go to example 6 when we have two different source, which is the first one is voltage and the second one is current. But for this question, we want to calculate the current through the resistor R equals to 20 and another one resistor which is 40 ohm. So at this particular point, you have a node here, okay, junction here, you have node here, then you can write the equation of KCL at this point. Because I1 plus I2, okay, minus with 2 ampere. So masuk